See beta, this is another question from the same grand test by question number 16. It is a ozone molecule they gave us. But instead of writing the O3, just they have written the structure also. O one side double bond, O one side single bond O. And they represented oxygen as A, B and C, and they're asking what is the formal charge on A, B and C respectively. But for finding the formal charge, actually this kind of the question, it belongs to the chemical bonding beta. And in this our chemical bonding we are having the concept called as a formal charge. It was given even in the NCERT also. Get the formal charge. But instead of telling the formal charge, this one what they gave in the NCERT and all, I will use my rule here to get the formal charge. What is the rule means? Let us go with example here. They give ozone molecule. So the first of all find out how many oxygens are there. So 3 into, but a number of electrons in the valence shell of oxygen atom. Number of electrons in valence shell of oxygen atom. If you do here, what will get 3 into 6, that is equal to 18. But this is 18 is the total number of electrons. But this 18 is nothing but the what? Total number of electrons. Means first step may find out the total number of electrons present in the given species. Species given is a ozone, sir. Ozone means 3 oxygen is there, and each oxygen containing number of electrons in their valence shell. So 6 is there, 18 is the total number of electrons. Then try to make the structure of it. O bonded with O, bonded with O. Means out of these 18 electron beta, we used these, we are using 2 electron to make a 1 bond. Again we are using 2 more electron to make a 1 more bond. 2 plus 2 how many? 4 electron we utilize. Remaining 14 electron left with us. Now but these all the 14 electrons we have to utilize to complete the octet of surrounding atom. See, out of this 14 I am using 2 here, 2 here and 2 here. Means 2, 4, 6 plus 2, 8. It is stable beta. In this case, 2, 4, 6 plus 2, 8. This is stable. But out of 14, how many electron we utilize? Sir, 2, 4, 6, 8, 10, 12. Again, 2 more left. Give for the middle oxygen atom. But still, this central oxygen atom does not complete its octet. 2, 4, 6. So in such a case, what to do? This is a trick given by Sudhir sir. What is that? But one of the lone pair present on adjacent atom take out and again put the double bond here and here. Now you can see these oxygen also completed octet. 2, 4, 6 and 8. This oxygen completed its octet. 2, 4, 6 and 8. This oxygen also completed octet. 2, 4, 6 and 2, 8. Means all the atom they completed their octet. Now one trick is there for formal charge beta. Formal charge is equal to actual number of valence electron minus at present number of valence electron. Is it clear beta? Actual number of valence electron minus at present number of valence electron. For these oxygen atom, actual number of valence electron for this oxygen is 6 minus at present beta 1, 2, 3, 4, 5, 6, 7. This electron don't count. 1, 2, 3, 4, 5, 6, 7. But these oxygen atom having a formal charge of -1. But these oxygen actual number of electron in the valence shell of oxygen 6, but at present 1, 2, 3, 4, 5, 6. Sir, 6 minus 6 equal to 0. No formal charge. But in these oxygen check it. Actual number 6 minus at present 1, 2, 3, 4, 5. So 6 minus 5 equal to +1. This oxygen will have a +1 as the formal charge. But what they decided? This single atom O is a, central atom is a B, and double atom O is a C. But A will have formal charge -1. Yes sir, -1. B will have formal charge +1. Yes sir, +1. C will have formal charge 0. 0. Our option 2 is correct. Right? Take a screenshot. But in this question you see here, question number 17, 4F14 they gave. That configuration will be observed in where? Do you know whether this particular question it belongs to our F block element? And I hope beta you know a block element it is present at the 6th period as well as on the 7th period. Beta in 6th period it will start from cerium to lutetium atomic number 58 to 71, and beta in 7th period it start from atomic number 90 to atomic number 103. That means it start from thorium to beta lawrencium 90 to 103. That means particular these elements are there. Even you know beta sixth period is also called as a 4F series, so seventh period is called as a 5F series. They are asking 4F, means obviously these should be there. But a cerium to lutetium, we don't remember the atomic number, better you remember last element lutetium. See beta lutetium is here and lutetium is here, but here Tm is there and Yb beta. How to remember the Yb and Tm? So just you can see beta कि lutetium and this cerium, in between that Yb will come, and Tm is the element beta, it come under the actinide series. So our answer should come as a first option. Yb and Lu are these elements come under the 4F14 configuration. Means if you write the lutetium configuration of beta, I am getting the 4F14. At the same time I will get for Yb also the configuration I am getting here as a 4F14. Then question number 18, check it here. Beta this is a question belongs to S block element. Beta in S block it is a question belongs to 2A group element called as a alkaline earth metal. They wrote barium sulfate and magnesium sulfate are readily soluble in water. But why this? One small concept is there. If any compound which is having a higher hydration energy, it will be easily soluble in the water. Now beryllium sulfate, magnesium sulfate, if you want to find out better, ki hydration energy of beryllium and hydration energy of magnesium. Hydration energy of beryllium and magnesium will be greater than the lattice energy of beryllium and magnesium. But it is a statement given in the NCERT. Be plus 2 and Mg plus 2 will have a higher hydration energy than its a lattice energy. So obviously this cation which is having a higher hydration energy than the lattice energy, so that compound formed by that cation should be a easily soluble in the water. Means we can say beryllium sulfate and magnesium sulfate are easily soluble in the water. Statement 1 is true, because the greater the hydration energy of two cations which will overcome the lattice energy of beryllium sulfate and magnesium sulfate, as greater the hydration easily soluble. Statement 2 also correct. So our option first is correct, where 1 and 2 are the true statement. But this is a question, sign of delta H and delta S, again coming from the thermodynamic part. See beta, this is our second type. In the one paper only we got a two thermodynamic, means more important chapter will be there. For this reaction, what is the sign of delta H and delta S? Beta, one trick I will tell you. As the number of moles of the gaseous increases, gas moles increases, entropy increases. Entropy means delta S increases. The number of gaseous moles increases, entropy increases. Check it here, sir. Cl2 gas, it is a 1 mole. Converted into 2Cl gas, it is a 2 mole. But a 1 mole to 2 mole, obviously my change of entropy delta S will increase. Means delta S value become positive. Negative no use, positive yes, negative no use. Our answer in between the 2 and 3 beta. This is a molecule, means obviously you know chlorine bonded with a chlorine and converted into chlorine atom, means we are supplying the energy to break the bond, and you know but the amount of energy required to break the bond, is nothing but the endothermic reactions. Endothermic means my delta H value should be positive. So my delta H value should be positive. So delta S is positive means this is not there, this is there, this is there, this is not there. Our answer between 2 and 3 beta. And as the amount of energy we are providing means amount of energy get absorbed, it is an endothermic process, so delta H also positive. This is not there, as such should come as a second option, where delta H is a positive beta, means it is a delta H is the positive, means it is an endothermic reaction, and during this reaction entropy value increases. As the entropy value increases beta, our delta S value also increases. So which option correct beta here? Second option is correct, right? Chalo, take a screenshot of this one. See beta, this is one of the question. At particular temperature, pressure, the mixture of gases contains some mole of N2 and O2. Volume of the mixture is what? But you know, these are the questions belongs to states of matter. And I hope in states of matter, everybody knows that what is the ideal gas equation. But you know, ideal gas equation can be written as what? PV equal to nRT. What they gave? They give pressure. Yes, sir. They are asking volume. So V is equal to nRT by P. But N means number of moles. But we are having, see, N2 also there and O2 is there. So better to write beta. This is number of moles of N2 plus number of moles of O2. Beta into R into T by P is the pressure. Beta number of moles of N2 how many? Sir, it is a 0.8. O2 how many beta? 0.7. By pressure is 180 m. Beta R value 0.0821 liter atmosphere. Kelvin inverse mole inverse can be written as 22.4 by 273, can be written as 1 by 12. Anything simple, better take beta 1 by 12. R key value. Temperature T beta 127. We know that 127 degrees centigrade converted into Kelvin 23, it become a 400 Kelvin. So temperature is equal to 400 Kelvin. Beta you solve it. Already I solved this one. I got 49.99. So volume is equal to 50 liters. Fourth option is here. But I saw in exam most of the children they are using this value of R as a 0.0821 liter atmosphere. Kelvin inverse, mole inverse. It will take much time to get the answer. Trick, remember only trick. Instead of that 22.4 by 273 we can use, or better 1 by 12 we can use. But this also gives equal to here, and this also value also equal to this much only. And substitute the value and get the answer. Right? Take a screenshot beta.